I am B. Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. Welcome to the lecture session of image processing. In this session, we are going to learn some basic concepts in sampling and quantization. Along with this, we will also learn how to represent digital images. So coming to the topics, today we are going to cover in sampling and quantization. We are going to see why we need to do sampling and why quantization is required. After that, to understand how to represent digital images, here we need to learn how to represent digital images and how many different ways are there to represent digital images. Now, so in the previous sessions, we have covered image sensing and acquisition. So in continuous with that, we need to learn about sampling and quantization. So before going to sampling and quantization, that means in order to perform these particular techniques on the image should be acquiesced. That means the image should be first captured, then only that particular any operation can be done on the image. So generally whatever we see the images around us, it will be in the form of three-dimensional, but when it is acquired by any sensor, then that particular image will be in terms of two-dimensional and it will be represented in the form f of x comma y. So here these x and y are called spatial coordinates. So x and y are called spatial coordinates, whereas here f represent the intensity level. So here f represents the intensity level, or it can also be called as gray level. So in order to call image as a digital image, the values of this x, y and f should be finite and discrete. Then only that particular image is called a digital images. So here, first we need to understand what is this sampling and quantization, why we need to go to that sampling and quantization. After applying these techniques, how the image will be converted. So first we need to learn about different types of images. So here images are classified into two types. One is analog image, another one is digital image. So which image is called as analog image? Generally any image can be represented in two-dimensional, that is f of x comma y. So considering this function, when we call that image as a analog image and when we call that particular image as a digital image, means based on the values of x, y and f, that is based on the values of spatial coordinates and the value of intensity level. So considering analog image, how will be the values of x, y and f means? So the values of x, y and f, all these values will be continuous in nature. Then that image is called analog image. Coming to digital image, if the values of this x, y and f are all finite and discrete quantities, then that image is called digital image. Now, our main intention is to convert analog image to digital image. We will learn what is the necessity we have to convert analog to digital, what are the advantages if we convert analog image into digital image. So, and what is the process to convert analog image to digital image? We are going to learn all that concepts. Now, So as I told here, why analog to digital conversion? That means the image that is captured, it will be continuous in nature. That is, that image is called as analog image. We have to convert that image into digital image. So why we need to convert analog image to digital image? Why directly the analog image cannot be processed? So here, the main reason to convert analog image into digital image is in order to remove the noise. If we want to resize that particular captured image, then compulsory it should be converted into digital. And another reason is if we want to extract any information from the image, then it is possible if we convert analog image into digital image. So all these are some of the reasons to convert analog image to digital image. So if we convert analog image to digital image, then it is very easy to process. So to process images, compulsory it should be converted into digital form. If we convert analog image into digital form, we are going to have some advantages like, so processing speed will be high and it is cost effective, and based on the storage constraint also it is very efficient and efficient transmission, and it is easy for the human in order to interpret the image. So these are all the advantages if we are going to convert analog image into digital image. So we have learned now why to convert analog image to digital image and what are the advantages if we convert analog image into digital image. Now we have to see what are the techniques to be applied to convert analog image into digital image. Now, so based on that, here to create a digital image, we need to convert the continuous sensed data into digital form. So this is the simple block diagram which will show the process of converting analog image to digital image. So here the input image which we have acquired will be generally in the form of analog. It will be continuous in manner, and that image should be converted into digital image. So in order to do this conversion, here two steps need to be followed. The two steps are, one is sampling, another one is quantization. So what happens in sampling and what happens in quantization means, as we have learned, image will be represented in the form of f of x comma y. So in order to convert this image into digital, here the two blocks, sampling and quantization, will be used. Now, so what will be happening in the sampling block means, here these two x and y are called the spatial coordinates. So the sampling block is used to digitize the values of spatial coordinates x and y. So here this sampling is used to digitize the values of the coordinates x and y. And whereas here quantization block, so this quantization is used to digitize the value of f. So here this quantization is used to digitize the value of f. That means this quantization is used to digitize the value of intensity. Okay. So then the whole image f of x comma y, continuous image, that is analog image, then it will be converted into digital. So sampling is going to digitize the values of x and y, whereas quantization is used to digitize the value of f, that is intensity level. So this is a simple block diagram which will be doing analog to digital conversion, and this is the purpose of sampling and quantization what we are learning. Now, so as we have discussed about this sampling and quantization, if we consider the image f of x comma y, that is the image what we have acquired, it will be in the form of two-dimensional and it is represented as continuous image. And that continuous image, in the continuous image, how should be the values of x, y and amplitude means the value of x, y and f, that is amplitude, will be considered as here f in this. Okay, it will be continuous in nature. In order to convert that particular f of x comma y analog image into digital form, we have to sample the function f of x comma y in both the directions. So what are here both the directions means? One is according to coordinates x and y and another one is according to amplitude. So sampling block will be doing the work of x and y, whereas the amplitude block will be performing with respect, quantization block will be performing with respect to amplitude f. So here digitizing the coordinate values are here x and y is called sampling, whereas digitizing the values of amplitude is called quantization. So here according to the function, the amplitude is represented as f. Now, so this is the simple graph or pictures which will be clearly saying how the quantization and sampling and quantization will be performed. For example, coming in detail about these diagrams. So here you can see the first figure. It is the continuous image. So if we observe this image generally, so in this figure we can see different ranges of intensity levels. For example, here the intensity level is different. It is white in color and here also it is white in color. But whereas if you see this, at this area it is black color and at this area some shades of gray color is appearing. So that is why if you consider this continuous image, this image is consisting of different levels of different values of intensity levels. And so, and this is the continuous image which I have to convert into digital form. And that is why after this continuous image to convert into digital form, here we have to take the two important steps what we have discussed. One is sampling, another one is quantization. So these are the two things we have to consider in order to convert this analog signal which is having different values of intensity levels into digital. Now, so in this analog signal, we can see here one line segment. Here the line segment is passing through this image and it is indicated as A, B. Now considering that line segment, what we can observe here in this line segment from A to B, at this area the intensity level is different, it is white in color, and here also the intensity level is different and it is also purely white in color. If we observe this area, it is different, the intensity level is different, somewhat it is looking like black, whereas here in this range it is not pure black or white, different shades of grey, different shades of grey level, grey color is available. Now we have to convert this particular continuous image into digital image. by using this sampling and quantization. Now, so considering this line segment A and B, we are going to draw a scan line. Okay. So if we observe this figure, here are the 2 points A and B. So generally, so as we have discussed previously, okay, so generally if the color is black, it will be indicated as 0. If the color is white, it will be indicated as 1. Okay, so in between this 0 and 1, we are having 0.5, which will be showing the value of gray. And the values present in between these ranges will be the shades of black and white. And so here at this part, as there is pure white available, if the color is white across this line segment A and B at the ends of A and B, here there is a peak value as the value of white is 1. As you come across this line segment after reaching this point, okay, so after reaching this point, it is having some black color. So slowly it will be reducing to 0 because while black is indicated with 0. That's why here graph is suddenly reduced to 0 because it has entered into the black. And after that, at this duration, slowly we are observing the value above 0 because it is having the shades of gray, that is around 0.5. So that's why up to this region we are having shades of gray. That's why here we can observe again the value will be increases from 0 to 0.5 and above. Okay, after reaching again the value, again it is going to reach the black color. That's why the graph is again being reduced to 0, as at this end the color is purely black as it is indicated with 0. After reaching here, again from this point to B, we are having pure white. So the value is again increasing as the value of white is indicated as high. So that is how we are going to have a scan line. And while having this, we are going to observe here some distortion in this graph. That distortion here at this point and at this point also some distortion can be observed. That distortion is due to noise in the image. Now, next step we are going to do sampling, and in order to perform sampling, we are going to digitize the values of X and Y. So here sampling means we can observe here at the bottom there is a scale indicated, okay, and this scale is divided into equal intervals. And so this is the waveform what we have got in the previous step. And so this scale, after dividing with equal values at the bottom, these lines should be projected onto this waveform. So equally spaced intervals at the bottom of the graph should be projected to the graph, and we can observe here after projecting, and if it touches into the graph, we can indicate these points, and these points are called samples. Then the image will be converted into discrete image. So if we extend here, if we extend these equally spaced intervals at the bottom onto the graph, we will see here the sampling process. The sampling process can be done, and the image will be converted, continuous image will be converted into discrete image. Now, so in this way, we are going to digitize the values of X and Y. So from the bottom of the equally spaced interval line. Now, so coming to this quantization. Quantization means digitizing the value of intensity. That is digitizing the value of F. So here we can observe there is a scale indicated, and here this particular scale is divided into 8 parts, and the bottom part here is clearly representing pure black, and if it goes to the, that is 0. If you go in the middle, it is the value approximately 0.5, which indicates the gray color, and if you go to the top of this scale, it is pure white in color, where its value is 1. Okay, so in this scale we can observe the values from black to white, that is 0 to 1, and the value which is present in between is 0.5, which indicates the shades of black and white. We can call it as a gray color. Now, so indicating this, we can also project this onto the graph, which will be indicating the values of that particular color. So this is used to represent the digitized value of amplitude F. And so after making this, the image, after eliminating this noise and considering here, we can observe small square boxes, white in color, square boxes, those are called samples. If we eliminate all these noise and this analysis, and if we draw this separately, only the samples can be seen here. Okay, so this graph we can call as a digital scan line. So in this is the process that should be done to convert this analog image into digital image. Okay, so this is the complete process of sampling and quantization, and why sampling is required, why quantization is required, what is the purpose of converting analog signal to digital signal, and how the process will operate, how the internal blocks of sampling and quantization will be operated. Now, coming to the next topic, representing digital images. So here the image is considered as a two-dimensional function f of x comma y, where this x and y are called the spatial coordinates, and this f is called intensity or gray level. So if the values of this x, y and f are all finite, discrete and positive values, then that image can be called as a digital image. So generally here image can be represented like this. Okay, image can be represented in the form of rows and columns. So this axis will indicate x and this axis will indicate y. Okay, so x indicates the number of rows and y indicates the number of columns. Okay, so here if we consider what are the different coordinate means, so starting from here you can have here all the x coordinates in the rows, x0, x1, x2, x3, x4 and so on, and here y0, y1, y2, y3 and so on. And what will be the value at this particular point means it will be x0 comma y0, and the value at this point will be x0 comma y1 row and column, and here x0 comma y2 and here x0 comma y3. So similarly here x coordinate is x1, x1 comma y coordinate is y0, x1 comma y0, and here x1 comma y1, x1 comma y2, x1 comma y3, and here similarly we will have different coordinates of x and y. We can observe here nowhere the values will be same. We can have different intensity values at each point. Okay. So here what are the values, number of coordinates, x coordinates you can take and number of y values you can take means the number of x values and y values are finite. That means here we can consider the number of rows as m and the number of columns as n. So we can say that the value of x will be ranging from 0 to m minus 1, as we have considered here from 0, and here the value of y will be ranging from 0 to n minus 1, where here m and n represents the number of rows and columns. Now, so here there are different ways in order to represent digital images. We will see one by one. Now, so this is one way of representing digital image. So here we can observe this is the image plotted as a surface. In this figure, we can observe there are three axes like x, y, and they are indicated with the function f of x comma y. So considering these three, f of x comma y is a function of spatial coordinates x and y. But this is one way of representing digital image. But this representation is not preferable. Why? Because sometimes we may be having complex images and too many details will be available in that particular image. If so, what happens? In order to interpret that particular type of complex images, representation need to be very difficult. So that is why this type of representing digital images is not preferable. And there are another ways also to represent digital images. So another way to represent digital image is image displayed as a visual intensity array. Here also image generally here there is x, y, and this is the origin which will be represented as the function of f of x comma y. So here f of x comma y is a function of spatial coordinates x and y, and image is displayed according to visual intensity levels. So here according to visual intensity levels, here we can observe three types of intensity levels are available. What are the three? Here it is totally black, and this is white which is represented as 1, black is with 0, and here you can see the shades of grey where its intensity value will be approximately 0.5. So if you represent digital image using this method, as it is according to the visual intensity level, it will appear as how we are seeing on the screens and also photographs. So, and this method is most familiar and it is widely used as it is supporting this visual intensity level. And this is another method of representing digital images. And there is also one more way to represent digital images. So f of x comma y is a function of spatial coordinates x and y, and this is one of the representation of digital images. So in this figure we can observe it is represented in the form of a numerical values. Here you can see different numerical values. 0 is there and another numerical value 1 is also there, and some numerical values like 0.5 is also available. So using these three numerical values only, they are going to represent an image as 0, representing the color black, and 1 representing the color white, and 0.5 representing the color grey. So, if you see this figure, image is displayed according to the numerical values. We have used here 3 intensity levels, and this method is most familiar and widely used. So, other than the first method, remaining 2 methods generally they are used in order to represent the digital images. And these digital images can also be represented in the form of a matrix. So, as I have explained in the previous slides, so image can be represented like this. So, here there is f of x comma y. X and y are the spatial coordinates. So, here x is available and y is available. So, here f of x comma y represent the pixel value of each element. So, here starting from here, these small dots are available, which are called pixels, and starting from here we can observe the dots are available. All these are called the elements of an array. So, what will be the value at this particular point means it will be 0, 0, and at this value it is 0, 1, at this value 0, 2, whereas coming to the next row, the value here will be 1, 0, and here 1, 1, and here 1, 2. Like that, the coordinate each pixel will be having its own value. And so here x and y are the spatial coordinates, and they should be finite. That means here it may be m, and it may be the value of y may be n, and the m represents the number of rows and n represents the number of columns. So the value of x will be ranging from 0 to m minus 1, and the value of y will be ranging from 0 to n minus 1. So here m and n represents the number of rows and columns, and that m and n should be positive integers. Whatever we are selecting, the number of rows and columns, they should be positive integers. And the same thing can also be represented in the form of a matrix, that is with the help of m by n matrix. M represents rows and n represents columns. It can be represented in the form of a two-dimensional function f of x comma y. So here, as I have seen, 0, 0, 0, 1, like that. Here it will be represented with like f of 0, 0, f of 0, 1, and so on, f of 0, n minus 1. As the value of y is ranging from 0 to n minus 1, here you will have n minus 1. And here we can observe the last one. Okay. Now, from this, f of m minus 1 comma 0 means here this is the value of x. X is ranging from 0 to m minus 1. Now, so here we can observe in this matrix different elements are available. Different elements are available. Okay. So each element that is available in this matrix, generally they are called, so these are called image elements or picture elements or pixel or well. But mostly we are going to use the term pixel. So in this, m and n represents the number of rows and columns, and they should be positive numbers, whereas the number of intensity levels, that means the values of, here we are talking about the value of f, okay, and here we are talking about the value of x and y, here we are talking about the value of f. X and y should be positive integers, and the value of f, that is amplitude, intensity, also should be limited. How much it should be means, intensity level, L represents intensity level, L should be equal to 2 power k. So what is that k? K k is any other integer value. So why the value of this intensity level f should be limited means due to some reasons like, so due to processing, due to storage, sampling, hardware considerations. So based on all this, we should take the value of this intensity level as finite and it should be L is equal to 2 power k. Now, so after making all the values of m, n and f, if we want to store that particular image, how many number of bits are required? Here there is a formula to calculate that. So here the number of bits are considered as b. After converting the image into digital image, how many number of bits are required to represent that particular image? Is b is equal to m into n into k. Here m and n represents, m represents the number of rows and n represents the number of columns, and here k represents any integer value. So here b is equal to m into n into k. So if we consider any matrix which is any image which is represented in the matrix, and in that matrix if the values of rows and columns are same, then we can write m is equal to n. Then the formula of b will be modified as n square into k, because m is equal to n, both will be same, both will become n, it is represented as n square into k. Now here we can observe the table which is showing the number of storage bits for various values of n and k. So here various values of n and k are available. So generally we know the formula L is equal to 2 power k. So here as L is equal to 2, if we want to represent the value of L is equal to 2, that means k value will be 1. That is why here k is represented as 1. For this L is equal to 4. If L is equal to 4, it is represented as 2 square, where here 2 is the value of k. So that's why here k value is considered as 2 and here k value is considered as 1. Similarly, k is 3, k is 4, k is 5, k is 6. Okay, so here k value is 7 and k value is 8. So considering all the values of different values of k, we can also observe here these represents the values of n. Okay. So for example, if first one we will take, if n is equal to 32 and if the value of k is equal to 1, then how many number of bits are required to store that digital image means b is equal to n square into k, which is 32 square into k. B is equal to 1024. Okay. So similarly, if you consider this another one for the same, n value is equal to 32 and k value is equal to 2. Now, if you want to calculate the number of bits required to store that image, it can be written as n square into k. So here n is 32 whole square into here k is 2 and the value of b will be equal to 2048. So similarly we can check for different values of n and k and we can calculate the number of bits required to store the digital image. So in this topic we have learned different ways in order to represent the digital images. Now, so the topics whatever we have discussed, that is sampling and quantization and representation of digital images, we have taken from the digital image processing textbook, which is written by Gonzalez. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.